Hello, welcome back to another video in Math 20 Trigonometry. The last few videos we took a look at the cosine law, and today we're going to look at the other trig ratio, which is sine. So we can take a look at the sine law. Just like the sine law, just like the cosine law, we're going to use the same notation. Capital letters, are the angles. Capital letters are the angles. And the sides are the small letters. There are two versions of sine law and cosine law. Each is meant to help you solve for side or angles, but ultimately they are really the same. Sine law states that the ratio between a side to it's the sine of the opposite angle. Or maybe, I think in science 10 we usually start with the angle and the opposite side. So I should say sine of an angle to the opposite side. Always the same for the same triangle. This again works for all triangles, just like the cosine law. Sine law happens. We can use sine law. Usually when we cannot use cosine law, or we cannot get enough information to use cosine law. But really, what's really important is that it relies on the fact you need to know one of the angles and the opposite side. So to use sine law, we must know one pair of angle and the opposite side, because we need to know, basically we need to figure it out what that ratio is. So we have to know a pair of opposite and angle. So this gives us two scenarios we might face. First, you might be given two angles and a side. So angle, side, and of course the side would be hopefully opposite to one of the angles, but we will see. And we will see why that some extraneous scenarios which the side is not the opposite. What can we do? But we can always find a known angle and side opposites. The other scenario would be if you have two sides and an angle. It might look similar to the cosine law scenario, but it's not quite the same, because before it's SAS, the angle is between the two sides. Now, in this second scenario, the angle is opposite one of the sides, right? The angle is on the outside. So making one of the sides the opposite. So this is different. We'll focus more on that in a little bit. First, we'll do a few examples concerning the angle side scenario. So we're going to do a few problems using that. Once again, the notes right above goes through how you can derive the cosine law, but we're not going to worry about that. Our focus is how to use it to solve this problem. So here, how can we use sine law to help us solve the problem? Now, remember, when I started, I said that you need to know one angle and the opposite. One angle and the ratio with the opposite. Or sine of the angle, I should say. Let me rewrite that. Sine of the angle to its opposite. We need to know one of them. And here we have that. Okay, let's label the triangle here. It's a little A, little B. Oh no, that's not a little B, it's a little C. This is a little B. Now, look at this triangle. Which angle opposite side pair do we know? That's right. We know B, angle B, and little b. That's our known. Okay. Now, to use sine law, remember, sine law is set up in a way it's the ratio between the sine of the angle and its opposite side are equal. So, in order to use sine law, we should also find that our unknown should also be in a angle opposite side pair. Our unknown is right here. Our unknown is C. I'm going to highlight that in blue. So C is our unknown. Okay, so that must go with the angle C pair. Angle C pair. So that's our unknown. That is our known. Now, once we know what we're looking for, we can set it up. We're looking for C. So that's why we would use the side version. We would write side in the numerator. So C over sine of C is equal to B over sine of B. All right, we're solving for C. We're solving for C. Before we proceed, though, we should check. Do we know all the information? Side B is 6.6, no problem. Angle B is 64 degrees. This is a known pair, so this is definitely okay. C and sine C. Oh, wait a second. I don't know what big C is or little c is. Okay, what shall we do? Okay. We don't know what C is. Pause for a second. We don't know what angle C is, which we need to use sine law. Can we find it? Pause the video and think about that. Alright, hope you did pause the video and actually think about it a little bit. How do we find C? We need to find this first, before we can substitute and solve. Okay, and it's actually very easy because we have the sum of the angles inside a triangle adds up to 180. So angle C is just equal to, I'm gonna make it red now just to make it stand out. It's just 180 minus 72 degrees and 64 degrees away. When you, it's 180. When you subtract them away, we get angle C is just 44 degrees, which we can use into our sine law equation. So now we know everything. We can rewrite C over sine of 44 degrees. Don't forget, change your calculator degree mode. B was 6.6. Angle B, sine, remember, sine of angle B is sine of 64 degrees. It's right there. So C must equal to 6.6 by multiplying both sides by denominator, just like we did in the previous unit. In rational equations, by multiplying both, not exactly the same, because it's not really an equation. Like rational equation, it's not exactly a rational equation. All right, and we punch this into our calculator, gave us approximately 5.10. So that is our length, approximate length at least, with 3 sig. Okay, to our missing side. Or you can, if you want, I think I used X. Okay, so this is how you can use sine law to find a missing angle. Okay, to find sine law to find a missing angle or missing side. I meant it's the missing side, not missing angle. I'm looking at the second question. Missing side. All right. The second question is very similar. Okay, very similar. Okay. Except we are given way more information than we need. We're given side, 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 and an angle. Okay, and an angle. Notice you do have an SAS, right? You have an SAS. Okay, you also have a SSS. Okay, so you can indeed use the cosine law to help you find this angle. Okay, to help find this angle because we have enough information. But for practice sake, we're going to, I don't know what happened there. Okay, for practice sake, we are going to use the sine law to solve this problem. And use sine law, we need to identify a known pair and known pair of angle and opposite side. Let's label it A, B, and C. So this is little a, little b, little c. A known pair, of course, known is angle A and little a. What we're looking for, x is right here. Unknown is angle B and little b. And we're looking for little b. That's our x. So, we're not looking for little b, we're looking for big B. We're looking for big B. That's our x. Okay, that's our x. So, set up the sine law. How would you set up the sine law? Okay, how would you set up sine law? We know known, we know unknown. Remember, sine of the angle over side is equal to sine angle over side. Sine unknown over unknown side is equal to known sine known over known, or vice versa, Okay, this form right up here. Okay, all right, I'll leave that for you to try it out. The last one is enigmatic though. Last one is quite interesting. Okay, last one is quite interesting. If you look, we do not quite have an opposite side or angle. Okay, think about the last one a little bit. Okay, but I'll leave you to really think about the last one. We can't use sine law. What can you do? Okay, what can you do? And with that, that's sine law, basic sine law in a nutshell. We're gonna solve some other sine law problems in our next video, and then we're gonna use that to expand on something very special about sine law. As you noticed, we only did AAS so far. So what about that SSA example? Okay, SSA example. So with that, thank you for watching, and I'll see you next time with some more sine law examples.